Alright, so we're now going to start transitioning a little bit. We're still going to use the same skills, but we're going to start transitioning to a topic that's going to be really, really important and really advantageous for you if you know how to do going into Algebra 2 and even into geometry, some students have told me. Because the regular algebra students aren't exposed to this skill, which, is a pretty advanced skill, but a really important one nonetheless. So for x plus h quantity squared equals x squared plus bx plus c, we determine that b is twice h and c is h squared. But how does b relate to c? How does b relate to c? Right, before we were comparing h or k to b or c, but now how does b itself compare to c? So let's look at it. And you might look at this example and say, how in the world am I going to figure out what to put in the blanks if I just know the 6? Well, you know that b is just twice h. And so if h is if b is 6, then h must be half as big, right? You could think of h as b over 2. So that must be 3 and 6. I guess we don't know the rest, so let's fill in the blanks here. And we know that c is h squared. H is 3 in the first one, so this is 9. The second one is 36. Continue to work forward, and then we'll come back and look for patterns. If you see them, you're welcome to pause and see if you can write down those patterns. We saw above that the relationship c is h squared. Another way to think of that is h is the square root of c. So if I know c is 16, h must be 4. And if h is 4, b is twice it, so 8. And finally, h is the square root of c, which is 8. Twice it is 16. So these are perfect square trinomials. We're squaring them. Right, so these trinomials are x plus something squared times itself, right? So the question we're asking, of course, is what do these b values have to do with these c values? Sometimes some of them might not be obvious, but if we look at it algebraically, so we have h equal, so we can do what I had called y to y substitution. B over 2 must be the same as the square root of c. So I'm going to solve for c, because I think that becomes a little bit more obvious as to what's going on here. So I'm going to square both sides. So c is the same as half of b quantity squared. So let's look at that. So if I take half of b, that's 3, and then I square it, I get 9. Half of 12 is 6, squared is 36. Half of 8 is 4, squared 16. Half of 16 is 8, squared 64. So why is this important? Well, this is important because sometimes we're going to want to go backwards. We're going to want to create a squared binomial. Because if we do in equations, often we can take the square root of both sides and solve in a much simpler way. So we will start to see that in the next opening.